8th grade's lesson 4.2, determining slope and y-intercept. Just a reminder, keep throwing this at you. I'm going to keep throwing this at you because I'm hoping that it digs deeper and deeper into your brain and gets stuck there. This equation is like the name for a straight line on a graph. Y equals mx plus b. It's a lot of letters and no numbers. I get that. Where x and y are those coordinates that you remember seeing. So when x is something, you run it through a calculation and you'll get something else for y. So that's what these both represent. When x is some number, you run it through this calculation and you'll end up with y. So those are your coordinates. This m always represents the slope. I always refer to it as slope m, just to help my brain memorize that that m is standing for the slope. Recall that a slope is the rise over run on a line. So if I had a graph and there was a line on my graph, I could look and see what the slope m is by choosing a point on the line and then choosing another point on the line, finding out how much I had to rise to get to that point and then how much I had to run to get to that point. Rise, run. And so once I found out what those numbers were, that would be my slope m. Usually as a fraction because you've got the rise number over the run number. So let's say that was up 1 and over 3. That would be my slope m. It could be a whole number. Maybe it was up 3 and over 1. Depending on the line. It would depend on how far you went up and over. Also, you learned before that you can find the slope by choosing 2 points on the line and taking their coordinates, whatever they are, and then you can use that equation m equals y2 minus y1 over x2 minus x1, which is slowly but surely getting stuck into your head. So if I took the coordinates from y2 and subtract y1 here, and x2 and subtract x1 here, I would get my slope, which would end up being the same as whatever my rise over my run is. 2 ways to find it if you have a graph. The other number that is represented here is b. That refers to our y-intercept. Why they use the letter b, I have no idea. I call it my y-intercept just to help me remember that that's what that B represents, the y-intercept, even though B has nothing to do with it. It's called the y-intercept. And what they mean by y-intercept, if you recall, in the lesson that we talked about proportional relationships where the line went through origin, that should have been this, where the line went through origin, we didn't have anything here. That didn't exist. It was plus 0, so we just left it off. But now we've got lines that are not going through origin. They are still straight lines, so we have that, but they are not going through origin sometimes. They're coming through, or all times, so they're coming through the y-axis, and they're intercepting with the y-axis at different points. So maybe this was at a 0 on the x and 2 on the y, so it would be a y-intercept of 2. If this was going through at 5, your y-intercept would be 5. In a scenario, that would be the original cost of something, and we're going to get more deeply into that, and we kind of touched on that last lesson too. So probably already this is starting to fall into place. And so just also to remind you, the slope m, that's the one that the value changes depending on something. If we went bowling and they charged us for every game you play, this is the amount they charge for every game you play, but the cost will depend on x, the unknown amount of games that you will play. The y-intercept is a one-time value that's not going to change depending on something. So that, in our bowling scenario, would represent like the shoe rental. I just have to pay the shoe rental when I get there. They don't charge me for every game. That's a one-time fee. That's what this number represents. And again, this is a y-intercept. It's where our line, this line, will cross the y-axis. So let's take a look at this example here. This is from page 103. We have this graph we have a straight line going through 4 on the y-axis, through 4 on the y-axis. That's the y-intercept. We have it leaning back. And what you're going to start noticing is when these lines are leaning back as opposed to leaning forward, I guess is the best way to describe it, you can know that you've got a negative slope m. If it's leaning forward, you know it's a positive slope m. So that's something you're going to start noticing. So here I have a negative slope m. I'm going to show you the example there shows you how to use that slope formula to find the slope using these 2 points. So, and then I'm going to show you another way afterwards. So here is our formula. M equals y2 minus y1 over x2 minus x1. That formula keeps getting more and more into my brain so that it'll be memorized soon. These are my coordinates that I'm looking at. Now, sometimes I notice my students have an easier time if they line these up. There's my first set of coordinates. There's my second set of coordinates. These are my 1s and these are my 2s. So, in fact, I will write that above it. This is my, well, actually, I'll leave it like that. All right. So, now I have my x's and now I have my y's. X1 this, y1 this, x2 this, y2 that. So now I'm going to go ahead and plug in those numbers. M equals y2 is 6 from here, y2, minus y1 is 4 over x2 is negative 3 minus, and x1 is 0. Now I just do the calculation. 6 minus 4 is 2. Negative 3 minus none is still negative 3. And if any of them, remember this is this number divided by this number, positive divided by negative means the answer is going to be a negative. So either one can show as negative on that. We'll just make that negative right in front of the answer. If this was a negative divided by a negative, then it would have ended up a positive. All right. So here we are, a negative 2/3 slope, which we already knew that was going to be because they gave us the equation and that said so. So this is just kind of exploring, if they didn't give you that, how you can use points on the line to find it. That's one way. The other way is, if this is a negative slope, then either of these needs to be negative. So if they'd given me this equation, or actually if they hadn't, I would start at a point, even if they hadn't, even if they just showed me the line, I would start at a point from here maybe, and find another point here maybe. And in order to get there, I would rise 2, so that's a positive 2 on my rise, and then I would go negative 3 on my run. Positive divided by negative, and you get the same thing. Or you could have gone the other way, found another point. I like where they intersect perfectly. Negative 2 as my rise, positive 3 as my run. Negative divided by positive means I'm going to get a negative answer. So I'm just showing you all these ways. Slowly but surely they'll sink in. Be patient with your brain on that. All right, so here's a scenario where a salesperson is paid a weekly salary each week, no matter what the hours that they are working is what they're paid. But they also get paid a commission, like a bonus, for each phone that they sell. We don't know how much the commission is for how much they sell. We really don't even know what the weekly salary is. But we are given this information that for numbers of phones sold, that's how much the weekly income was for the salesperson. So we could use this data and work it backwards to find out not only how much they are getting per phone that they sell as a commission or bonus, but also what their normal weekly salary is. So I went ahead and wrote down this information in a table because the previous problems have been having us use a table. So I wanted your brains to have that jump. So 10 phones, then the salesperson earned $480 of weekly salary plus commission. 20 phones, $630. 30 phones, $780. 40 phones, $930. So to see if this is proportional, I'm going to take these 2 points and compare them in our slope formula, m equals y2 minus y1 over x2 minus x1. Then I'm going to do the same with these 2 points, just to make sure that everything is staying nice and proportional. So I'll start with these 2 points. This is my xy for choice 2. This is my xy for choice 1. And I'm going to run it through our formula, y2 minus y1 over x2 minus x1 to find the slope or unit rate. Slope and unit rate, same thing. Y2 minus y1, this is my y2 and this is my y1. Oh, if you need this, I'll put this x and y here. There we go. Y2 minus y1, 630 minus 480. And x2 minus x1, 20 minus 10. I do those calculations. And then the final example on page 105, they're just letting you know, and it's kind of something you already would catch, I think, that you can use the y-intercept to find the slope in this equation. And to me, it's a little confusing the way to explain it. I'm hoping I can clear it up and just so that you make sense of what they're saying. Just to talk about y-intercept again, remember that in the equation is this part y equals mx plus b. This is the y-intercept. It's wherever it is that it's 0 on the x and you turn and go somewhere on the y, either positive or negative. It's the starting amount. So 0 on the x, turn, go b on the y. This, if I had these coordinates 0, b, 0 on the x, turn, and go b, whatever that's going to be, I don't know yet, on the y, so I just put b there. If you're comparing it to another set of coordinates somewhere else on the line, let's say I had a set of coordinates there, and I knew that its coordinates were, I knew their numbers. I don't in this case, so I'm just going to call them x, y. That example on page 105 is just showing you that you can take that known set and then just take the y-intercept once they tell you what it is and know that it's a 0 on the x and that number, whatever it is, on the y as coordinates. So you can use them as coordinates is all they're trying to get across to you. So when you fill that in, it would be y2, which in this case is y, minus y1, which is b, over x2, which is in this case x, minus x1, which is 0. And then you would calculate it. So they just are trying to point out to you that if you're given the y-intercept, then you would know, let's say we had a problem that was mx plus 5, then what you're going to know about this coordinate on the coordinate plane is that it's 0 on the x, turn, and go 5 on the y. So you can give it coordinates of 0 on the x, turn, and 5 on the y, in case you need to use those coordinates for something as a point on the line to run through this equation to find your slope. That's all that section is talking about. It's just recognizing that this has a set of coordinates, 0 on the x, turn, 5 on the y, because it's where it intersects with the y number line. So it's always going to be 0 on the x.